Okay guys, so welcome to this tutorial, and let's go into the core of the matter. And today we are going to be talking about GitLab for CI/CD. Okay, GitLab for CI/CD. So we have the objective of taking you from beginner to a professional. Okay, so this is the start for that objective. Okay, so my name is Wright Baku. I am a DevOps engineer. I am equally a consultant to different companies that those doing a cloud migration, those doing that are already on cloud and need some maintenance of the system. Okay, the goal of this video is to share knowledge and for us to learn and have fun. Okay, so cloud is something that is very cool. I believe it's a topic of the day because it has numerous advantages. So this is my way of contributing in the move to cloud. And at DevOps spot, we encourage that move to cloud, and we share our knowledge. Okay, for people that want to learn, for those that are already maybe into the field, to maybe learn a new skill, to maybe learn a new way of doing something. Okay, or a new tool. So let's go to the content of the day. So today we're going to be talking about so we have 6 slides, not much, right? Not much, but the content is quite huge, what you're going to learn. So we are actually going to answer the question, why GitLab among other CI/CD platforms. We have the learning goal for today, the objective of this video, and the GitLab terminology to get familiar with, from understanding YAML, how your code live from YAML into to materialize to your pipeline. Then we have a demo showing step by step how you live from your YAML. You write your YAML, you understand the different blocks of your code that materializes to give your pipeline. So for somebody that is just getting starting with GitLab, here is the best video for you, because you understand the keyword, you understand the terminologies, and then you understand how all of these come in play for you to have a pipeline that is very, very functional. Okay, whether you're a dev or a DevOps engineer or somebody that actually is curious to know about this. So at the end, after the demo, we'll have some resources for you to be able to continue this journey. Okay, so let's start. So now the question to why GitLab? Now you know, in the market, in the field, there are other CI/CD tools. Namely, we have Jenkins, we have GitHub Actions, we have GitLab, just to name a few. Now, why GitLab? What makes GitLab stand out? Why did we choose GitLab? So in this case, GitLab is an all-in-one DevOps platform. Okay, with GitLab, you can have a whole plethora of tools all in the platform itself. Okay, so you are not obliged to stitch, tools from different platform. You install maybe SonarQube on another platform, you install maybe Maven on another platform, another registry somewhere. All of this is all integrated in GitLab. You can have this all in one place. Mind you, for those that are into artificial intelligence, you can actually store your models in GitLab. Okay, you can equally have for those that are familiar with Terraform, you can actually have your backend in GitLab. So all of this is just a whole all-in-one, like the word says, all-in-one. For everything that you want to do, you can do it all in GitLab. That is the cool part. And your code, that is the additional one, that GitHub Action also has the code repository at the same point where you have your CI/CD. Contrary to Jenkins, because Jenkins, you have just the CI/CD, and you have to actually maybe check out your code from somewhere else, like cloning your code from somewhere, so that you can actually do some work on it, some test also, or build. Okay, another reason is because GitLab is security minded. Okay, security is actually barely in function, it's built in GitLab. So with just 2 lines of code, you can have a whole SAS test, DAS test, to a static application security testing and dynamic application security testing. You know, so with just a single line of code, you can have all this run in your code. If you're doing Python code or whatever language you're doing, you just write these 2 lines, and you can, for your code, analyze for security and vulnerabilities. Okay, so that is actually a very interesting point when it's, especially if you're in an organization where security policies are really very serious for you. Okay, the last point, just to name 3 because there is more here. GitLab is very beginner friendly, because if you're a beginner, you are really skeptical about certain things, you don't really know how to go about. So with GitLab, you already have what we call auto DevOps. So you can just submit your code, like commit your code immediately. If you select the option auto DevOps, GitLab can actually auto generate a pipeline that can actually evaluate your code for you without you doing anything, you understand? So it facilitates you onboarding the tool. You can actually take the tool fast and learn it as quick as possible. So with all this, you can see that GitLab actually is the best option. I would actually recommend GitLab because for the different places, the companies that I've worked, I have actually recommended GitLab, and they really find the advantage of using GitLab. So that said, let's continue to the next slide. So today we have a goal. So what is the pipeline goal for today? It's just like the traditional DevOps pipeline. So we are going to have a pipeline that goes from, so we are going to plan actually how our pipeline is going to look like. Then our pipeline is going to, then we have good code, right? We're going to plan the nature of the different steps that we're going to execute on our code. Then we code, okay? We code, we have a code, and then from that, we take that code, the pipeline builds, okay, and test, then deploys that code, okay? There is actually a step in between testing and deploying, which is doing a release, okay? So this is the workflow of what we are going to do. Now, based on your different use cases, you might add other stages in between, but this is the goal of today's lesson or today's video, okay? Okay, so we said there are some terminologies that we need to get familiar with in this case, in the case of GitLab. So there are some terminologies you need to know so that it does not cause some confusion. So the first one is project. Project, yeah, project in GitLab actually it represents a code repository. A code repository because in GitHub it's called a repository. In GitLab it's called a project. So just to know, that's where your code is found. Your GitLab configuration, your pipeline configuration file is actually found, which is the .gitlab-ci.yml. Okay, so everything about your code, match requests are here. So we have a pipeline. You know, the pipeline is a set of jobs that execute, that run in a defined order. Okay, then jobs. So jobs is a single task on a pipeline. Okay, it's a single task, but a single task can be made of more commands. Okay, so the job is a single task, so there can be multiple commands that execute a particular task. A task can be just like a build. Let's build our code. So for you to build your code, maybe a series of commands that come in is check out the cd into a particular directory, and then run the execute a command to build. You understand? So there can be more commands found in a job, but a job is a single task in a pipeline. Then we have a runner. In the case of GitLab, the virtual machine, the machine or the machine that actually runs your job is called a runner. The machine that executes your job is called a runner. And then we have what is called an executor. An executor can be confused at times as a runner, but it's not the same thing. An executor, the executor is the environment type a runner uses to run jobs. Okay, so for an example, we have a shell runner. If you say a shell executor, sorry, we have a shell executor. A shell executor runs directly on the machine. Then we have a Docker executor. A Docker executor runs in a container, which is very cool because when you have a shell executor, it runs just in one machine, making it less scalable. Okay, but when you have with containers, you can have multiple containers on a single machine, making it possible for many jobs to run in those containers. You get the point? So we equally have a Docker autoscaler executor. This is just like a Docker executor. The difference is that with a Docker autoscaler executor, it creates machines on demand and then use those machines as Docker executors. Understand? So when a job comes, a machine is created that will be used as a Docker executor, and when the job is done, then the machine is terminated, then it's just auto scaled. Understand? So making it very cost effective. I would make a video about that, and you will find that this is a very cool setup, and actually that is a setup that is used in the organization where I work. We have a Kubernetes executor, and the Kubernetes executor is, you can just say it's like a Docker executor, because the Docker executor uses, but in the Docker executor it uses containers. In Kubernetes executor it uses pods. That is the difference. That is just the difference. Okay. Now, so we have in GitLab, I mentioned at one point that GitLab has a configuration file to put, from which it uses to create a pipeline. So that configuration file is written in the YAML language. YAML, which is just a human readable data format for configuration, and it's used to declare a pipeline. Okay, so in the context of gitlab-ci.yml, the .gitlab-ci.yml file is a declarative configuration file that describes what you want the pipeline to do and not how to do it. Okay, so you declare what you want your pipeline to do, but not how to do it. So what does declaration mean here? So declaration means I want a pipeline with these jobs using these stages and rules. So you declare all this high. For example, I need 3 jobs, 2 stages, and with certain rules. Based on that, GitLab will interpret that. So on the part of GitLab, GitLab has a GitLab CI/CD linter which passes the YAML. So it passes the YAML and uses the internal CI parser and interpreter to validate your YAML. After it validates the YAML, it checks for syntax error, because when you have a syntax error, your pipeline will not even execute. You have an error without seeing the pipeline, because it checks your pipeline for syntax error, and if there's no syntax error, it checks the job dependency, checks the rules and conditions. When it gets an understanding of all this, it now produces an internal directed graph of jobs and stages. This is just to say it will produce you a chronological order of your jobs based on your declaration in your YAML. When all this is all known to GitLab, this chronological order of your job, then your jobs are ready to be set to be collected by your runner. Like we said, a runner is the virtual machine that picks up and executes your jobs. So when GitLab has already created a directed graph of jobs and stages, a runner picks up the job. Okay, a runner picks up the job. Okay, the cool part. Yeah, so this is the demo part. For this demo part, we are going to use some essential keywords. These keywords are like definitions of blocks in GitLab. The number 1 is stages. Stages actually define the stages of the pipeline. So when you start writing the YAML of your pipeline, stages defines the stages that you have. So when you just, at a glance, if you see a pipeline, you will just find stages, and below that you will see the list of stages. From there you can already know that for this pipeline there are going to be so and so number of stages, because under stages you have a list of all the stages that will be used in the pipeline. Okay, from there we have job name. So the job name can be whatever you define. It's the name of your job. And then we have stage. So stage is a keyword that is used under the job definition, because it declares where, under which stage this job belongs, because GitLab collects all jobs that belong to one stage and classify them under a stage, so that when you produce an internal graph of the stages and jobs, you will see them in an organized order. Then we have script, and script is the part where you align the commands that will be executed in your job. Simple, we are going to see that. And then image is simply, we mentioned the Docker executor. So image is the image that we define that will be used to run our job. So for example, if you are using Java Spring, you use, for example, a Maven image, that would be able to do an MVN test, MVN command. So you use that image because it already contains maybe Java installation, the dependency that you need. So in that environment, it's already adapted to execute your code. Next, we have artifacts. Artifact is another keyword that it's used to save files from job to another. So when you need chronological passing of some certain files, maybe some artifacts, some files, some builds, some result from previous job to other jobs, you use artifacts. Okay, for example, you run test, and after the test is done, you have some JSON files, you have some XML files. All those files, maybe you need it in a subsequent job, which is maybe supposed to expose this this result in maybe whatever platform that you need. You understand? So that job will need the results of a previous job. In order for you to pass those test results from one job to another, you're going to define artifacts. So artifact keyword will be used. Next, we have the neat. So we have the neat keyword. The neat keyword tells GitLab that one job depends on another, which is very important because by default, GitLab, if you don't use the neat keyword, it actually assumes that the previous job is a prerequisite for this following job. So if there is job 1, job 2, job 3, job 2 needs job 1, job 3 needs job 2. So it's a cyclic dependency. So, or let's say it's a linear dependency. So that is what GitLab is going to use. But if you think that there is no linear dependency, for example, maybe stage 3 does not necessarily, job 3 does not necessarily need job 2 to actually terminate before it can start. So you can actually say you can precise now that job 3 does not need job 2. By doing what you need to precise that, you need the neat keyword to define that job 3 does not need job 2. So the moment job 1 finishes executing, job 3 can already start executing because it does not have to wait for job 2. You get it? Yeah. So now let's go into the demo, the cool part. Okay. So for this, you need a GitLab account. Okay. So we are in this is my GitLab account. You just go to gitlab.com. You just subscribe to an account. You just create a new account. Use your email. You create an account, and you just have an interface just like mine. So here is the first keyword that this is the first terminology that we defined previously in a slide. So we have projects. So we need to create a new project because we need to deposit our code in a project. So when I click on project, okay, so we can actually create either a blank project, we can create a project from a template, we can import a project from example GitHub, Bitbucket. Okay, we can actually run a CI/CD for external repository. So you don't actually want to import the whole code. You can actually run the pipeline using the code that is based on another repository. So but here we are going to create from a template because we are not going to code from scratch now. So I will use the code Java Spring code. So this is the option. So I get here and I click on use template. So let's say I want to create a project that's called let's say Microsoft. So now this is good. So I need to define a namespace or a group. So namespace here can be my username. So if I do the drop down, it can either be a user or a group. So if you create a project as a user, that means that project belongs to you. So if you need to give permission to somebody, you have to explicitly assign permission or invite somebody into that project. But in a collaborative environment, it is recommended for you to create projects in group because groups already have members that are assigned to group. If you go to a team, there is maybe a group for front-end developers, back-end developers. So for the back-end developers, they belong to a certain group. So if you are creating a project, you create a project in that group so that all of them would automatically have access to that project. So it is recommended to create a project that needs collaboration using a group. But in this case, I'm going to use my personal user because this project does not need collaboration. It's just for the sake of learning. Okay, so I don't need to add any descriptions, and this is a private repository, so I keep it private and then create. Good. Okay, so the project was successfully imported. Good. So this is really fast, guys. So we have the project already imported, so we can actually work on this because we needed some Spring code, some Java Spring code that can permit us to test, to learn how to write our pipeline. And then, like I mentioned, auto DevOps. So now imagine we already have in our template a template pipeline that has been given to us here, you see. So we have a template pipeline here that can be used to actually build our code and do more. So based on this, we can now actually add some flesh to this and tailor it in the way that we would want it to be. So that is good. So now you remember we talked about some keywords. So let's go over these keywords just to understand how this pipeline works. Afterwards, we are going to clone this repository, do some modification, commit this code, and have our pipeline running, and we can visibly see all the stages and everything running. It's easy, guys. It's easy, but you just have to know the keywords and know when to use which, and based on your different use cases, which keyword should I add to my pipeline based on what I needed to do. Okay, so we start with stages. You remember we talked about stages. Stages with S actually here would list every stage that is going to be used in this pipeline. So from the look, we know that there are going to be 3 stages here, and this is how GitLab also sees it when you receive the YAML. It already creates boxes for 3 stages. It knows that there are going to be 3 stages in this pipeline. Okay, now there is this include, but we are not going to use include today, but I'm going to make another video some other time that is going to talk about other keywords, because the difference with GitLab is just the keywords. Okay, the different keywords permit you to do more stuff. So include, and I equally mentioned at one point that with just 2 lines you can add security scanning in your pipeline, and this is it. This is the line. This include actually it's used to import or to bring a different pipeline configuration file from somewhere else, so that it comes and runs in your own actual pipeline. So we are including a pipeline for dependency scanning. So with this alone, GitLab has already written a whole dependency scanning with the best practices. When you include this, it's going to scan the code that you have and produce you a dependency scan result. But we're not going to do this now. I will create a DevSecOps video where we are going to do all the security scanning. So for today, we are focusing on creating a functional pipeline. Okay, so understanding a functional pipeline too. So we have here build job. So here is job name. Actually, this is the job name, and you can name it whatever you want, and just in front you have a colon, and then we have stages. You see, all of these now are under the job. These are different keywords used for the job definition. So now stage without S, stage now picks a stage here and attach and define in a job which this declares in a job which stage this job belongs to. So this job, the build job, belongs to the build stage. You get it? So if you want to add a new stage, you just need to add a new stage in the list of stages and then call it up in the job that you want to add. Okay, and then we have script section. These are the different commands that are executed in a job. Sorry. So for the build job, we have 2 commands: the compiling, so compiling the code, compile completed. So these are placeholders. Actually, subsequently we are going to use real commands that actually build the code, and we can see practically like it's done in incorporation. So we have a unit test job. So the job itself is already self-defining. So it's a unit test job. You can name it how you want, but somebody should be able to pick up your code and know what you meant when you wrote the job name. And then this stage, the stage here is test, meaning this job belongs to the stage called test. Okay, so what GitLab does, if there are many jobs that belongs to test stage, it will group them under a stage called test, almost like a table. So just like we said, continuing, so you see it's simple because this for these 3 jobs we have just 3 keywords that have been used here: the job name, the stage, the script. Same thing, and same thing here. Now for the deploy job, we have deploy, which is the job name, we have stage, we have script. Now environment is something really special, and we are going to talk about it in a subsequent video. Okay, it's almost like creating an environment. When you're doing deployment in another environment, you name it differently. So we are going to see that as we advance in our journey from to live from a beginner to a professional. Okay, so let's go over and pull and clone this project. So I'll just go do a drop down. I get the URL to clone this using HTTPS. Now I will go to the VS Code. Here I am in the VS Code code editor. So here we are going to clone the repository and then do some modification and push this commit and see how our pipeline goes in action. Okay, so let's git clone the URL. I paste the URL that I copied from the project. Great, so we have the code. So let's check out to the folder. Great, here we are. So I'm just going to do a code here. This is a literal way of saying code here, but with VS Code you just do code done. It means open a coding environment here because it's a code editor. Okay, okay, so we have a coding environment that has been opened here. So the file that concerns us here, because we are talking about pipeline, is the .gitlab-ci.yml. So the .ci.yml file, here is it. And like we said, we are not going to be doing the security vulnerability scan today. We're not going to scan the dependency in this video. So I will take out this section. Okay, and that is all I'm going to do for this file right now. So the first step is to run this and see what happens. Okay, are you ready, guys? So let's open a new terminal. Okay guys, so let's do a git status to see if anything changed. Git status, yeah, of course something changed. So we edited the file and saved it. So now let's add these modifications. Okay, so let's commit this. So we use git commit -m. This is to pass the commit message, and the commit message that I'm going to add here is simply remove SAST scan. Okay, now the code has been committed. We have the commit. Now we just have one thing to do: push this commit and see our pipeline come in action. Okay, so let's go git push. So this pushes it to the master branch because I am still in the same branch that I put. Good. So at this moment our pipeline is supposed to be running. This is the cool magic of GitLab. So let's go here. Good. So I just have to do F5. You see, so this blue icon here shows that our pipeline is running. You see, it's running. So you can actually click here and be carried and be redirected to the pipeline, or you can come to builds and then you see pipelines and then click on pipelines. You see, get to the pipelines. Now first job has been a success. So you see the first job, the build job, has been successful. The the build job is in the build stage. We had 2 jobs in the test stage. So the first one is already successful, 1 more left to go. Then we have the last job, which is the deploy job. Deploy job under the deploy stage. Okay, so you get it. So what GitLab does, it takes every job that was declared according to the stage where they were declared, and then aligns those jobs under the stage, almost like a table, right? So here you can actually find out that these jobs are already organized. Now let us go into a job and see how to understand the GitLab logs. So this is the build job, which actually is just mimicking actually a job. We're going to actually do a real build command subsequently. Just after this, we're going to do a build command that actually builds the code, builds the Java code. So we're going to see that after this, but this was the first commit and first push for us to see how the auto DevOps, the pilot, how GitLab automatically takes the job and runs it immediately as you just push. Okay, you don't have to configure any webhook, you don't have to configure anything, just declare your pipeline and execute. And the good thing about GitLab is that we have free runners. Okay, with the GitLab, when you create a GitLab account, you don't need to add runners, because there are free runners with GitLab that can actually run your jobs. But remember, these runners are good for test projects, not company projects. Okay, you just use them for learning and doing some things that are not critical. Okay, so now looking at this log interface, the job interface, so we have here the duration. So on the right, you can see the duration of the job. It took 30 seconds, and then it finished already 2 minutes ago, and the job was queued for 0 seconds. So the job just immediately it started, it was already assigned to a runner, and then it started to execute it. And then we have timeout. Timeout is actually a value that indicates if a pipeline, if a job takes more than an hour, it should actually declare timeout, because it will fail at that moment because it's more than this timeout duration that has been defined for 1 hour. But this value is customizable. You can define it to 10 hours depending on your use cases and your needs. We have runner. So this defines the runner that picked up our job. So here is the name of the runner that picked up our job, and its ID is this. So the source was from a push, right? So a push action that caused the pipeline to be executed. So that is the information on your right. Now, when we look closely to the logs, so at the beginning you can see GitLab is pulling a Docker image called Ruby. That is the default function that has been configured for the runners that we are using, because it uses a Ruby image. And then with the Ruby image, then it pulls the image, and then inside that image, because this is a Docker executor, because Docker executor permits us to run multiple jobs in isolated environment. So it pulls a Docker image called Ruby version 3 or 3.1, and then we execute different commands that are in our script section of the job in it. So the 2 commands that we defined in our script section was compiling. It just needed to echo compiling the code, and then echo compile complete. Okay, and this was done successfully. So like I said, now we are going to use actual Java commands to build the code, because we have a code. You remember, we have a code, so let's build that. Okay, here we are in the GitLab configuration, the GitLab pipeline configuration file. So here we are going to replace the script section with actual commands. So we are using Spring, and Spring uses MVN commands to be able to test. So I will just grab some commands from a previous project I was working on. Good. So the build job has been replaced. So the first command is going to be an MVN clean install -d skip test. So this actually indicates to Maven to skip the test, because what you do when you do an MVN clean install, it installs and then does tests. Okay, but when you indicate that skip test, it will just do a build alone. Okay, and then after that we have a build complete. It should just echo for us build complete, so that we know that it went through. And then we need to do a unit test. So unit test command is simply good. So we're just going to do MVN test. It's going to run unit test, and then at the end it will just echo test complete. The next, we're going to do some linting. Great. You see? So with the lint, we're going to use mvn check style colon check. Okay. And then for the deploy job, we are not going to do an actual deploy now, because deploying needs an actual infrastructure or a virtual machine that we're going to deploy on it. So there are certain actions that have to be done before actually running a deploy job, and we are going to do deploys in our subsequent videos. We're going to focus on deploying in a Docker Compose environment, deploying normal containers, and deploying in a Kubernetes environment. So for now, we're just going to echo deploying application, but then in your own environment, you just need to replace this with the commands that are used to deploy in your environment. Now, remember here, the image that was pulled here was Ruby, but Ruby cannot actually execute this because Ruby image does not have MVN. So we need an image that has MVN, which is Maven in it. So like we saw in a keyword definition, image just define the image that we use for our build. And then here you can notice that the image stands alone out of other blocks. When we do this, this means that the image becomes a default image that is used for every job. Now, this use case is because all our jobs use the same image. But if in your case your different jobs use different images, so for example your build image might need this Maven image, but your test image might need another image, say Java, say another image, or your security scan might need SonarQube image. So if you do this, it's going to actually be used for everyone. So you can actually go for the inside the job that you want to use a separate image, you can define there the image that you want. For example, if for my LinkedIn I needed to use another image which was different, I can just say here and I define image, you understand, and I just define and then I put the image that I need. For example, if I needed to use SonarQube, I would just put here SonarQube. Okay, and that would be used when it comes to this job. Is going to pull the SonarQube image from Docker Hub. So I will just remove this because this is not the case right now. Good. So I'm going to save this and let's run this pipeline by committing and pushing this simply. Just commit, push, and GitLab would handle running the pipeline and assigning it to a runner. Okay, so let's do git r. Then we do a git commit. So I will just call up the commit command that I already used here. Then I will change the commit message to use real commands. It can be anything that you want to say here, but the commit message is actually supposed to be descriptive of what you just did, what this commit is all about. Now I just have to push. Great, our push is done, so we know that our pipeline has automatically been evaluated and sent into the pipeline interpreter of GitLab, and our pipeline has been created and now it's running. So let's confirm that information. So when I come here, I just have to click on pipelines here, and hooray, we have our pipeline that is already started and is running. So when I just click, you see here, I can just come on the running and I click, and I can see that the build job already succeeded. That was fast, right? So okay, so what do you notice? It took a duration of 37 seconds to do the build, and then it finished already 21 seconds ago. This is the runner that picked up the job, and it was triggered by a push event, right? Now you can see that it actually is pulling some dependency from the Maven repository, and the build is complete. So the build has been done. Now we can exit. Good. Let me just do F5. Great. A job has failed, which is something that is quite normal. There's no cause for alarm. So you can see that the lint job has failed because the previous one, we just echoed a command. We just emitted a command to say that it was good, but now this is the practical case. Now we have linted the code to see if it's okay. You can see that the lint is saying that missing a Java doc comment, missing a Java doc comment. You see, there are different places where certain things are not okay. Parameter argument should be final. File does not end with a new line. Okay, you see, all these lints shows that these are not good things that you have done in your code, and so according to the lint check, this job is not okay, so it failed. So now the developer will have to analyze this and do certain corrections in his code, in his or her code, for it to be green. Okay, now notice one thing is that the deploy job has not run because we talked about the need, because when this is job 1, job 2, job 3, job 4, so but then now there are stages: stage 1, stage 2, stage 3. Now by default, if we do not state a need, GitLab assumes that the stage 2, which is the test stage, depends on stage 1, and stage 3 depends on stage 2, which is a linear dependency. Okay, which is a linear dependency. Now, but in some cases you will find out that some job they don't really need others, okay, in order to run. Like in this case, we want our deploy job to run anyways, despite the fact that the linked job has failed. Okay, but we want to use need to permit the deploy job to actually run. Meanwhile, the linked test job has failed. Okay, how do we do that? We need to use need to precise that this deploy job does not actually need linked in order to run. By so doing, even if the linked job fails, even though it's in this stage, the deploy job will still have to run because it does not necessarily need the linked, because we would have defined it that way. Okay, now let's do that. Okay, so in order to do that, we just got to go to the deploy job and define and use the need keyword. So just create a new line, easy, needs. Okay, so you can do it this way. You just have to open up a list. Okay, yep, and you just define them in strings. So now you just call the different jobs that you just define the jobs that the deploy job is gonna depend on. So what you are going to define here are the jobs that deploy job needs, and you can exclude those that it does not need by not mentioning them. Okay, so we are going to mention here that it needs the build job. Okay, copy that. Paste there. Okay, it needs the build job, comma, another string, it needs the unit test job, because we know that the unit test job was successful. So okay, okay, so here we have actually defined that the deploy job needs the build job and the unit test job. We notice that we did not mention the lint test job because it does not need the lint test job to execute. So the moment the build job and the unit test job are successful, the deploy job is going to run, no matter if the lint test job fails or succeeds. Okay, so that is all we got to do, and I will just save these. Okay, and then what do? We do a git add and commit. So now the commit is, I'm going to just change the commit message and say use need to reorder jobs. Good. So that is the commit message. I think that is best now, but you can always choose whatever message that you want, but just remember it has to be something describing what you did in this commit. So that is it. Now let's just push. Okay, our push is successful, meaning our pipeline should be up and running. Now we go to the pipeline section. Good, our pipeline is up and running. So let's go in, guys. Okay, pay attention to this, because now we have something that did not appear in the previous jobs, in the previous pipeline interface. Was this group jobs by stage dependency. So now, basing on this, if we click on dependency, you show dependencies, you see now there is something new here. This is an acyclic diagram, a graph that shows you a dependency. So if you hover over the deploy job, you will see the blue lines. It leads to the different jobs that it depends on. So you see that the deploy job shows here that it depends on the unit test job. When you go over, you see a blue line that goes through, but it goes beneath the lean test job, but it does not actually show that it depends on the lean test job. You see, the lean test job is out of the picture. It depends on the build job and the unit test job. You see, the lean test job has actually failed here, but the deploy job is running anyways. And that is the cool part, because based on this, you can use it to optimize the build time, because there are certain jobs that might be waiting, meanwhile they actually don't need the previous step. So you can actually define in those jobs that you don't need them. Okay, start as soon as possible. So when your pipeline starts, these jobs can start heading forward, because they don't need anybody behind them to actually start. Okay, so now these are the different decisions that come in your plan part. You remember our pipeline goals. You have to plan and know that, okay, what stage depends on the other stage. All this comes in the planning, but you have to know your keywords. Okay, let's get back to the slides. Okay, so we have gone over these keywords, but let me draw your attention to the fact that we have not used the artifacts. In the subsequent video, we are going to do artifacts. We are going to talk about how to use artifacts as a keyword. We are going to see how we use include. Last slide. So now let's talk about resources here. Just one resources, but very powerful, because now you already have the basis. Okay, you have the basis. Be confident you have the basis. You just need to take the pipeline template. Okay, and then basing on your needs, okay, you just pick a keyword and use it. If you need to use image, you just grab a keyword and use it. So this link actually it gives you access to every keyword that GitLab has. It's a perfect documentation that has been done by GitLab. So let me just take you a bit. Let's go through that. So this is the link address. So you see, these are keywords. These are all the keywords that are used, because that declaration files is all about keywords. If you know the keyword, your pipeline is going to work perfectly. So you can just go over this to add more flesh to the basis, to this knowledge that you already have. For each aspect that you want to implement, just refer to these keywords and pick it up and use it. When you go to this, you can always see the examples. For example, if you go to, say, include, we click on it, you see that include is going to give you how to use include with every details of the use cases that you might find yourself in. See, so there's quite a lot. We cannot really cover all the keywords, but the bases have been covered. So now every other new keyword that you might need is already found in this link that I'm going to share with you guys. Thank you guys, thank you for your attention. So don't forget to like our channel, because the purpose of this is to share knowledge, and for many people to be able to access this, we need we need more subscribers. We need you guys to share. Okay, thank you very much, and see you in our next video. Thank you. Bye bye.